Okay, students, we are looking at problem number two, and this problem gives us a resistance. So everybody's going to have a different problem, but I want to kind of like work with you on this one. So we're going to have ourselves a resistance or a resistor, and it has this voltage, at least on its label. So we refer to this as nominal, okay? And it's not necessarily measured resistance, all right? So this is our R that we are referring to here, okay? So that is that many ohms. Now, it has a band on there, and that band has a certain color, and that color is going to tell you its tolerance. So in this particular case, it's a plus and minus. In other words, this is our uncertainty, okay? It's 5%. And then we have ourselves a voltage here, okay? And I'll just use green again. And so typically I'm going to represent voltage, in particular DC voltage like this. You'll find it in other ways, but this will be my voltage on here. And it too has a um, error or an uncertainty associated with it. It too, it too has an uncertainty associated with it. And that uncertainty is 1.62. Okay. And now we get to our current, and our current is measured. Okay. So this is a measured current. So I want to set this circuit up for you so you can see how it should look. So we have ourselves a resistor here. We're going to have ourselves an ammeter in here. All right. We can literally put it anywhere, because the current through the entire circuit in this kind of circuit, which is a series circuit, is going to be the same. So we have our voltage down here. I typically represent it as a delta V, but in this case, I'm just going to use V since that's what I used at the top. I guess I could put delta V. Let me just behave. Delta V. And then I have I here. And all of these are properly, I want to say that they are going to be properly associated with the values that have been given here, okay? So this A with a circle around it, it represents a meter, an ammeter, all right? So let's just continue right on. Now, we want to know the measured resistance. So we know that we can use Ohm's law, which is V equals to I times R. Now, one of the things I want you to know is you still have a voltage across this resistor, and you have a current through this resistor. We know that current is the same throughout the entire circuit, so it doesn't matter where you put it, that's where it is. And so let's see here. So you see how we have our current measured that way? Well, um, I'll skip that part. I'll skip that part. Let's go ahead and calculate our resistance. So resistance is just going to be V over I, and this I has to be the measured I, okay? So let's just go ahead and take our delta V, and I should say delta V, okay? And let me place a delta V here. So this is just going to be equal to, what is that? Delta V is 18 volts. Do not leave your units off. Mistake will be a mistake. 0.24 times 10 to the negative third amperes. Even if I do it, it is a mistake. I'm saying mistake. All right. So just move that over for a little bit. And of course, we can do this in my script calculator, but I'm going to go ahead and take this information over to Microsoft Excel. Okay. And so I really need to do it like this. Bring up Excel, put it right here. And so I like Excel. It's very powerful and it's quite useful. So the first thing that I'll do is I'm just going to type in, resistance. So I should probably say nominal or the expected value of the resistance. And because I don't know how to put a symbol in here for omega, I'm just going to type in OHM because it is just as useful. And I am going to keep going. And I want to put in my voltage. And I think I should say, yes, voltage here. I almost wanted to say battery, but it doesn't have to be a battery. It could be something else. Um, Voltage, and I'm going to put this in volts. Okay, and then we have our measured current. So notice what I'm doing. I'm trying to type in as much information as I possibly can about the system. Um, and I would suggest that you do the same thing. And this is going to be in amperes. Okay. Now, I'm going to say that right next to it, I want to go ahead and insert the uncertainty. So let me do this real quick. Let me wrap my text and let me go ahead and middle and center it for readability, not only for you, but for me, okay, or whoever else might be looking at this work. So I'm going to say uncertainty, uh, and we're using tolerance here. So I'm going to say resistor tolerance. All right. And this tolerance is actually a percentage. Okay. And let's do the same thing for voltage. So I'll just do the same thing. Voltage, tolerance. I would rather say something else, but I'm just going to, I'm going to put tolerance and I'll just have to suffer if I'm incorrect. Should probably be some good suffering. And then we're going to have our current and it's going to have a tolerance as well. So, mm, okay, from these things, so you see, this tolerance, this is not tolerance. This is voltage um, spread. I would imagine all of them could be um, written with tolerance, but in this particular case, we actually have voltage. So you see, we have resistance tolerance here, and then we have like the spread in the voltage or the measurable, yeah, I'll say that the voltage measurable voltage spread. How about that? Measured voltage spread. And this is what this is going to be. This is going to be a plus or minus value. So I think that I can put that in there. Okay, plus or minus. All right. Even the tolerance here is a plus or minus. And I'm going to put percentage. Mess that one up. Don't need shift. All right, so that should hold right there. And then we have a current. And I don't want to use current tolerance. I want to use measured current spread. If you come up with a better way to say this, totally fine, as long as you understand what's going on here. And this is like the variation. It's like you have a mean and then you have a spread about it. Okay, and this is what this is going to represent. And this is actually in amperes. So I'm trying to distinguish it between percentage and amperes. We're going to produce a percentage anyway, but when it comes to uncertainty calculations. But let's go ahead and place our resistor value in. So, and for me, I have 2, 4, 3, 5. Okay. And then I have a tolerance of 5%. So I have to keep that in mind and I need to put 5% here. And then I have a voltage. In my case, it's 18. And then I have a spread of plus or minus 1.62. Then I have a current of 7.24. All right. And this is E negative 3. Okay. And then I have 5.1 E negative 4. So this is a plus or minus, and these are basically my uncertainties. Or yeah, I think all of it can fall under the uncertainty in measurement. So like error, tolerance, spread, all of these are speaking to the uncertainty that you have in your measurement. All right. So the very first thing that we want to do is we want to calculate the resistance in the resistor. Okay. And the resistance is going to be in ohms. All right, so let's go ahead and calculate that. And it is very similar to what we were talking about. It's the same thing. So you see that we have 18 volts or delta V over I. So what are we going to do? We see we have our formula here. And I'm going to make this, spread that out a little bit. So all this is equal to the voltage, not the spread, but the voltage divided by the measured current. Okay. And we get ourselves a value here. Okay. And I guess it's beneficial to look at this in terms of scientific, but we could also just make it a number, which will be fine here. In fact, let me give it 3 decimal places, increase my decimal place. All right. So we'll go with that for our ohms. This is the resistance of the resistor. Now, if you look at it, we have ourselves 2, 4, 3, 5 for our nominal resistor value. And then we have 2, 4, 8, 6 for our measured resistance. And I want to be specific. So I'm going to go ahead and say, mhm, okay. I don't want to. So there we go. This is our measured resistance, okay? And now we want to find the uncertainty